So all of you know that we are conducting this online mode of the training program on intelligent transportation system applications for
Sir, video is
highways.
not.
So,
Sir, video is not available.
oh, just a minute. Uh, yeah, today is the fifth day of this ongoing training program. We have already discussed various aspects of the topic during last 4 days. Today, basically, we will discuss on passenger and traveler information system. So I will request to the participant, please make it a two-way communication. Please interact with our faculty. Please ask your questions during the presentation as well as at the end of the presentation. During this 3 hour session, there will also be a 15-minute time break at around 11:15 to 11:30. So I also expect from the participant this program is that the, uh, there will be an interactive session between the expert and the participant so that participants get more benefits from these type of the training programs. So I will not take much more time. I request Sri Samir Sharma sir to start his presentation as well as his experience with the participants on the topic. Thank you.
Good morning and thank you, sir. So let me share my screen first.
Yes, sir. Visible, sir.
Okay. So good morning, everyone. So first, let me introduce myself. I'm Samir Sharma. I head the multimodal integration and last mile connectivity in NCR Transport Corporation. NCR Transport Corporation is a joint venture company of central government and NCR states. So we have 50% share of central government, and remaining 50% share is from Delhi, Uttar Pradesh, Haryana, and Rajasthan. Each one having 12.5%. And one of the mandate of forming NCR Transport Corporation was to implement the regional rapid transit system and implement in entire national capital region. I am a civil engineer with a master's degree in transport planning from School of Planning and Architecture, Delhi. Almost I'm reaching to 30 years in this field. I've worked in various countries. I've worked in various disciplines, starting from extensive work with even NHAI. Initially, when NHAI was doing in 2003-4 the road information system for national highways, I was part of that quite extensively. I was also part of Japan mission on ITS implementation, which came to Ministry of Road Transport and Highway, and that was one of the first initiative on implementing the intelligent transport system on the road sector in India. So I was part of that delegation, Japanese delegation, where we did a lot of research in this area. And subsequently, I was part in various committees on the traffic management, road safety. I'm certified road safety auditor also, and I'm a specialist in public transport system. This passenger and traveler information system actually pertain to various modes of transport. Therefore, this experience becomes more relevant. So I have experience in urban sector, regional sector, also internationally and domestically. So I mean, we'll discuss all of my experiences during this. I mean, today's interactive session. Little bit brief about what NCRTC is actually mandated to do. So you can see this NCR map actually, where you can see some radial lines. There are total 8 regional rapid transit corridors are identified. And when I say what is regional rapid transit system, it is, you can call it higher version of metro. So the speed of average speed of metro, if you see, is 33-34 kilometer, whereas our speed will be 3 times of the metro. So the highest speed will be, operational speed will be 160 kilometer per hour, but design speed will be 180 kilometer per hour, and that is first time in India it's being implemented, this kind of speed in the regional context. We are supposed to implement all these 8 projects, out of which 3 are prioritized projects, and one is under advanced stages of construction. So we are likely to open the first section next 6-7 months. So Delhi Ghaziabad Meerut is under advanced stages of construction, and March or April we are likely to open the first section of it, and then Delhi Alwar is also under advanced stages of approval, and Delhi Panipat also under DPR finalization and approval from the central government. uh, uh, this is going to change the way you travel in the national capital region. So that is little bit about myself and the organization I'm working. Now let's come to the real topic of traveler information system. Before we understand or get into the traveler information system, we have to understand the transport objective itself, that why these systems are important. So there are 3 core indicators, we say, while there can be many, but 3 core indicators we say in the transport, that the transport system should be safe, efficient, and the smart and intelligent. So safety, all of you know. Efficiency means that if you are going from A to B, then within the permissible limits of the system, it should able to take you in the shortest possible time, or shortest possible manner, or the most convenient manner. It should able to actually make that particular objective. And smart and intelligent, when we say in the today's context, then it means that it can be interactive, it can change the situation, it can inform you about the various things or adverse conditions, it can interact and understand your requirement, and then give you sufficient information to make the decision, so and so forth. And all of this smart and intelligent comes through the technology, various technology. So it's a mixture of the various things, and in fact all the 3 objectives of making this transport system efficient, safe, and smart and intelligent comes under the good passenger and traveler information system. So it really tried to achieve all these 3 indicators or objectives as part of the system. That's why it is very, very important in a country, if we want to really move towards a progressive transport system for the people, then we should have a good traveler information system. Now, if we really see the transport landscape, and this applies to urban and regional, both cases. You are starting your journey from your home, and you want to go somewhere. It may be 300 kilometer, 500 kilometer, whatever distance you want to go. The first thing is that how to reach, which route I should take. There are multiple decisions to make on this, and our transport network is now expanding very fast. So you can go with the expressway, you can go with the national highway, you can take the state highway. There may be little detour somewhere, but there may be differential in the speeds, there may be differential in the condition of the road. So there are multiple parameter under which the decision of the users actually regarding a particular mode or particular route happens when he's planning his journey. He can think that, okay, this route is very congested, so I should take the rail rather than the road. Or he can say, no, the rail take more time, so I should take the road because the road condition is good and it is faster, and so on and so forth. So the first thing is that at the start of your journey, each traveler needs certain information, whatever mode they are going. In fact, the information has to be the multimodal, so that they can make the right decision regarding their trip. So that is the first thing in the door to door mobility happens, that you have to plan your mode, you have to plan your route, and then take that particular information. So at the starting, some information is required. On the route also you need certain information. So if you are going through that particular journey, then you may actually try to see, I mean, some information related to, let's say, the wayside amenities. You may require some information on the fuel stations. You may require information on the some amenities related, and also related to the weather. I mean, if your journey is, let's say, 6 hours, 7 hours, 8 hours, and there's likely to happen some kind of change, major change in the weather, and there are places where the weather changes very fast. So that information also you need dynamic information, because you are traveling very in a longer distance, and there may be multiple routes, so the traffic condition may change. So on the way also you need some information on the traffic condition, so that you can make the decision that, okay, in between also whether you have to change your particular route. And then at the end of your journey, you may again need certain information. You may need that, where should I able to park my car. So if you are going to some, let's say, destination or tourist places somewhere, where you want to park your car somewhere for a few hours, and then take advantage of, or attend some meeting, and so on and so forth. So in that situation you need some information at the end of journey also, about the city, about the transport system, about the facilities available. Based on your trip journey purpose, you need the information. So there become three important steps which we'll discuss further. That initially you need some information, on the way you need some information, at the end of this you need certain information which has to put in. Then only once we take care of all of this, then only your journey becomes efficient. It also becomes safe, because once you are fed with the proper information, if the road condition is not good, or if there are some I mean, some dangerous situation is there, there is a stalled vehicle on the road, then this all helps you even to kind of make your journey safer. So in the door to door mobility from origin to destination is very important, from the transport authority perspective, to provide the information to the users, so that the right kind of I mean, decision can be taken. Now, in traveler information system, what it is a very simple thing. It is nothing but a set of technologies, or the equipments which are installed, and based on that technology, data collected, analyzed, and then given it to user in the usable form. So the data is converted into the information. So the technology, different technology forms collect the data from the various things, and then give it back to the user. And also the information system is helpful for making certain decision by the authority, which we'll see in the later slide. So it's nothing but a set of equipments by which the data is collected and dispensed or given to the kind of users which are actually your using your particular system. Now, what are the advantages? I mean, why should we do it? If we specifically come to that particular point, then from the user perspective, a good information will help the user to, let's say, save time. For example, if I don't have any information, I have taken certain routes, and you must be, who are actually staying in bigger cities, must be knowing that without seeing any map or traffic information, if you go, many times you get stuck, and you may actually not able to catch your flight, or may not attend your meeting timely. So the most important thing is that you actually, if you know the information about the congestion or some problem on the route, or the efficiency of the route, you can make the timely decision. There are many times in Delhi, for example, where we go by the car, and then uh, in the return, if it is a peak hour, we actually leave our car and ask driver to come and then take the metro, because on the traffic situation we get the information that if I use the car it may take 2 hours, and if I use the metro it may take 45 minutes. So if I want to save the 40 more than 1 hour of my time, I make that decision that, okay, driver will come, but I have to attend another meeting, so I take the metro. So I get drop nearest metro station and then use the metro, because it's a dedicated service and it's exclusive right of way. Therefore, the metro will not delay. So it basically helps you to make the timely decision, that how you want to actually use that information to the benefit of yourself. You can make real decision that, okay, I have to reach that time, then this is the best mode. So the information really help you to make that particular decision on this. Also, it helps you to actually correctly know. For example, many times what happens in Gurgaon, I'll not cross between this time to this time. Let me cross Gurgaon by 4 o'clock so that I reach timely on this. So the second point is the time of departure is also influenced by this. So I'm changing, if I don't have any information about the congestion and route condition, then I can start any time, and then I'm supposed to reach in 5 hours, I'll reach in 8 hours. So if I have information, then I little bit adjust of if I'm flexible with uh, my time of departure, so that the I know that, okay, in this particular time I'll get a little better traffic condition. The mode we discussed, that which mode is efficient to go, also I decide. So if there's a high traffic congestion by the road, I'll say no, I go by the rail. And also many times what happens is people alter their decision to go to certain destination. For example, I want to go on a family trip to, I mean, to certain restaurant in the evening, and I find that a restaurant actually which is outside the city and 25 kilometer on NH1, uh, if I want to go and visit that restaurant, and I find that that information on the traffic information tells me that there's a high congestion, I not go to that destination because my purpose is to go to the restaurant. So I'll change the destination itself. So there are multiple things, or I'm meeting a friend, or I'm meeting some office work people on the way or something, where I should meet. The destination itself can be changed if the right information is provided. So from the traveler perspective, it is very very important, especially where the traffic conditions are very dynamic, where I mean the situation changes very frequently. That in that situation, the traveler information system becomes very very important. The traveler information system, if your situation is not changing, may not be required. I mean, if you say the, okay, I don't have any dynamism in the entire system or transportation, then I mean, if the to the Jaipur, all the people want to travel to Jaipur between morning 9 to 10. Now the highway will actually full in no time, and everybody will get actually delayed in their journey time. So what this also traveler information does is that if there is a traffic congestion built in, it will ask users that, see, there's a delay. So some people will change their time. They'll, so we call it spreading of the peak hours. So rather than everybody traveling between those congested hours, people will try to actually change their journey timings, and it will make better use of the facility. So in certain cities, actually large metropolitan areas, if you really see, especially the North American cities, New York and all these places, this is considered one of the tool to spread the traffic between with the time and on the network also. So they provide the information and tell the user and try to tweak their timings and the routes if there's a congestion building in the network. So they'll, if you are going A to B, they'll try to tell you again and again that okay, you take this route because this is much better, this has less traffic, this is higher speed. If you do this, you will benefit it like this. Or if you are flexible with your time, travel between this time to this time. So the transport authority try to actually spread the traffic and try to use their transport facilities or road network in more efficient manner by informing the users, telling the user that, I mean, if you all are going to come, uh, it's like a shop where the two people are sitting and serving their customers, and all the day customers come in 10 minutes and they queue up, and then after they all go, then the shop is empty. This is the same situation in our transport network also. We also want people to use it. My capacity is 24/7. So if I use it only for 1 hour and then it's empty, it is not a good use of it. And I need, maybe right now I may have 6 lanes, I may need 50 lanes to handle that traffic, and then it will be empty for other things. So authority perspective also, it makes a lot of sense that we provide right information to the users so that the traffic is distributed and our uh, utility of the our facilities and investment is made use of it in a much better way compared to if it is only used in the particular hours of the time. It also helps the safety perspective, the behavior of the users. So when we say and analyze our road safety related issues, we find that frustration of the traffic. So you might have heard or uh, about the frustration or the fight on the road by the drivers. And one of the main reasons of this is the congestion. Actually, people who are frustrated on the road, they try to lose their temper very fast, and they are actually a lot of unsafe situations happens. But that can also be bit of mitigated if you really start giving them information. So in an overall sense, while this is not a direct benefit, but in an overall perspective of the things, if you see, it actually enhances the safety of the road users by kind of not making them too much frustrated. If a driver is frustrated and lost, let's say, 1 hour, and he has some urgency, he'll speed up. He will actually jump the red light. So all these frustrations actually eventually we as a country and as a city authority should give a lot of emphasis on this, because the benefits of it are huge, and the work related to the benefits are relatively less done from the government perspective. They are, we'll discuss about what work has been done by other countries, what is the past, present, and the future of it, and how actually we can strengthen our traveler information system on this. Now, if we come to the flow chart of that, how this happens, that it's a very simple four-stage flow chart which tells that you will have to collect the data. So, as an authority or as a private sector also. So, there are a lot of traveler information system which comes through the private sector also. So, whosoever is the operator of this traveler information system, they will have to collect the data from the various means. Some means are written here, but these are not the entire list of it. The list is increasing every day with the enhancement of the technology. The data collection methods are increasing in a multiple way, and data access is much easier, and the form of data is also enhancing. So that's a usefulness the useful part of this, that now the data is not that difficult to get because it's getting generated with the multiple things. So the first part is the data collection. Data can be collected from roadside equipments, embedded equipments. It can be actually collected through the vehicle props. You can have GPSs and the various systems of the government itself, wherein at the toll plaza, for example, if you are collecting certain data, or you have put in some CCTVs somewhere, you can take that particular data. If you have put in some signals, traffic signals, you can take that particular data. There are large number of, in fact, the speed cameras are put in multiple places. You can take the data from there. So there are multiple actually data sources available. Depends on which territory you are and which area you are, where what kind of equipments are there, and you try to assess that okay, this much data is available, and out of this much I can get. So additionally, what else I have to install? So a lot of data sources are there. From there the data is collected. Now data is not information, data is a data actually. Now it has to be converted into the right information to the user on this. So that data is converted to the information which is usable by the user through the data fusing. And there's a lot of data actually provided by the agencies, and that is actually bit of missing in our traveler information system right now. The integration of the data from the different agencies. For example, I'm doing a construction in a particular road. Now in a real good traveler information system, that data should come to the traveler information system, that okay, this here the half of the lane is blocked, and he should know at start of his journey itself that if you will use this particular road, one side of the road is blocked on this. Or let's say traffic police and there's a BIP movement or something is there, they blocked a particular road. uh, uh, so right now what happens is that if there's a maintenance or something is there, they'll just block it. So the once you reach to that spot, you realize that okay, this road is, oh my god, this is actually blocked today. So this information has to be facilitated in the traveler information system, so that people don't go there and then create more congestion and more problem to that particular work which is actually happening in there. So if you really see data fusion, where it is written, it's written agency A, agency B, agency C, because in the real good traveler information system owned by the government, the data actually, the main data comes from the various agencies, and it is integrated on a common platform, and from there then it is converted to the information. So each agency will have their own, like we are doing the construction on Delhi Meerut road, we must be having some 300-400 cameras. Now this information may be useful for somebody else to kind of observe the traffic condition, and can be, somebody can really run a AI on this, and then I mean there are a lot of softwares are available which can really tell you that okay, congested spots are there, and send the information to there. Likewise, there must be many agencies who are actually working in that particular area. They together come in, then they can really inform them, and it will help everybody. So the second stage is a data fusion, and then converting it to the uh, usable information. The third stage is a value added information. Now one is that you give only the information about the whatever you're collecting on this. Beyond that, you can also assist to. So what happens is that many times the users will, many times they may not be interested on this, because the information which you are providing to them is actually servicing a half of the purpose of them. So in any case, if they want to search something else, this also they'll search from somewhere else. So what some agencies did is that they also made it interesting by adding some value added information about the destination you are going. So for example, the wayside amenities information, about the information of the, let's say I'm going to a particular city, then I can give the information about some of the yellow pages there, that if this guy wants to go somewhere uh, there, then in that situation, they are actually not, they provide this additional information to kind of assist that user to have I mean their journey. This thing, in case I'm going to one city and I want to find out the good restaurant, then this information can be provided through that. Or I want to know that what particular thing actually is famous of that particular area, then I can provide that information. So I can also provide the information of weather or the news or the related interest of the area. So there are many agencies which make this information very useful. I mean, they give traffic information, they give road information, they give route information, but they give additional information so that it becomes more value added to the user, and more people use it. So that is the third part, though it is actually not uh, compulsory to be part of the value added, I mean, to be part of the traveler information system. But any value addition based on the particular geography is always helpful to attract more users. Your system is good only when the people use it. So that is the third stage on this. And the fourth part is the data distribution. Now, the way you collected the data through the various means, the data distribution also happens through the multiple modes by which. So, I mean, one can say that I'll give this data through the mobile phones. Now, mobile phones may be available with somebody or may not be available with somebody. So, what happens if I don't have the smartphone? Am I not supposed to get the information? I mean, in a inclusive places, in a I mean place where the everybody is supposed to get the information, we need to find the various means to provide the information so that some people are not only benefited but all are benefited. So that's how this emergence of providing the information by the various channels, media channels we call it, actually emerged. So now you have a various channels. So if you are a smartphone users, then the mobile app you can use. If you are not the smartphone users, you can get the information by the text message. Or there are places where I mean they you can get through the helpline. So we were doing this one project for ministry through the World Bank, where this operational control center was supposed to be set up, where there could be a single transport helpline number. You draw whatever 131, I mean what number could be anything. Now this number will give you the information of various things, various modes, this thing. So it will be a single helpline number by which, if I don't have internet, if I don't have anything on this, still I am actually supposed to get the information on this. And if we go on a higher side, then there are multiple things on your car. They can be a dashboard. On the dashboard you can continue to get the information on this. So there are various media channels available. They can be a radio, a simple radio with you, and you can get the information through FM. And within this thing also, there are very simple channels of giving the information are available. Information kiosk are there. You might have seen the airport, or maybe in malls, multiple malls, where there are kiosks are there, where you can see the map of the mall. This is the shop here. Likewise, there are information kiosks where you actually go to that terminal and then just click it, and it gives you, okay, from where you want to go to where. You just say this, it gives you all the information. It can be multilingual also. I mean, if you are from South India, then your language, it will give you the information. uh, so various channels of various types actually are considered as part of the traveler information system. So that's the fourth part of this, under which actually this entire system works. Now, this is a just simple diagram for a one case situation. So, let's say there are a lot of cars going, and today, for example, the way Google provides you the information, and mind you, the Google Maps which you use daily is not the entire or complete information system for this particular thing. Because what happens is that Google gives you a specific related traffic information to the certain attributes of it. uh, the advanced traveler information system actually gives you a lot of information for the other attributes also. But in a very simplest form of the traveler information we go, for example, in Google Map, you get the speed data or the time data of this. But many times you might have observed that it is telling you to take the long distance route. So the real distance must be 5 kilometer or 10 kilometer, but the route is telling you that okay, you take this 15-kilometer route by this, because it is actually taking the time into account, not the distance. But you are supposed to know the distances also. So in the higher versions, it is started with the giving some distances information. Then in the relatively higher version, it started giving you the information of certain that there is a stalled vehicle on this. Some information they started accumulated, though they are dependent on the crowdsourcing data. Therefore, there are certain limitation. But if you want to know in the Google that there's a construction delay somewhere, or there are maintenance happening on this. If there's no vehicle actually traveled on this particular route, or there is a gated community, and many times you might have seen that in a sorry, in a it will take you to a very small road on this thing. Now these limitation happens with that because the information is coming only through the crowdsourcing. So the government has a very strong database available from the various agencies of their work plans, their different kind of equipments by this. So in this, if you really see this traveler information system, the way all these the private sector information works, that you pick the information from the user itself. So the information is coming from the car, and through the your internet or cellular network, and then this is getting into the control center, and the same information. So the car ahead of you is giving the information of the speed or the congestion ahead. That information is going to the central server. It is getting back to the people who are actually following that particular car. So the first car is experiencing the congestion. In that situation, it is telling the car behind that there's a lower speed if you want to use this particular road. So the information is coming from the crowd. So the limitation of this source is that in a particular day, for example, on a particular road on which you want to go, there is no user traveled on this, or that user who's traveling is not allowed the access of their GPS tags to the Google. Now if you don't allow the access to this, then they'll not get the data. If they don't have the data, then what they'll do is they'll use the data of the last day. If the last day data is not there, they'll use the data before that last day, even 1 month old, it may be 1 year old, whatever. They have the layers of the data, and if the today this time data is not available, they'll use the whatever historical data or patterns are available with this. But many times they may not inform you that this is a whole data sets of this. So the private sector information system has some limitations on this, which we'll discuss in future slide also. So it's a very simple thing. The simplest information system is that you take the crowdsourced data from the users through their GPS, and then process it, and it's called simulation engines, and then give it back to the users. It's a very simple thing. The little more complicated is that apart from the GPS, you start taking the data from the CCTVs and other things, and start giving back to them through the multiple other channels of it. Now the question is that, is this kind of traveler information system works everywhere? Now, utility, while it is always useful to have the information about it, but the utility is more in certain situation. So, you may have a one place, let's say you have built one expressway. On that expressway, the congestion is not likely to build for long time. So the congestion information is not very relevant on that particular expressway. Only relevant information is that if you can tell the users, okay, you'll get a restaurant here, so he can plan, okay, I can break the journey and I can have the lunch there or something. You can give the information of the toll plazas, how much toll uh, he's going to be charged, what is the average speed. So similar kind of information can be given, but that is not the most crucial information. The most crucial information is where the traffic conditions are very dynamic and the traffic levels are very high, and there are multiple routes exist and there are multimodal modes are exist. So if I have only one, if I have, please mute your, yeah, speaker. Okay. So so the yeah, okay. So the traveler information. I think somebody's. Can you please mute your speakers? Okay. So the point here is that if you have a situation where you have multiple routes exist, there are multiple modes exist, there is a harsh weather condition, this kind of situation is there, then the traveler information system becomes very useful. Generally, it is useful in all cases, but it becomes more useful if this kind of situation exists in particular thing. If there is a one road, for example, and you want to go and there's no rail service from your place to that particular thing, then even if somebody tells you there is a congestion and you have an urgency to go, the maximum what you can do is you can try to see that okay, that I can change the timing, but then you have to use that particular road only, you have to use particular mode only. So the utility of the traveler information system is more where there's a higher congestion, there's a alternative routes available, there are multiple modes, and there are different type of situation in terms of the weather conditions exist on this. The quality of information is very important. If you provide the wrong information, for example, or sketchy information, so wrong information, when I say, if I provided a 1 day old information, so I am supposed to go on A to B, and the information system is telling that there's a high congestion on this, and somehow I go to the same route and I find that there's no congestion on that particular road, then I'll lose the faith in that particular system. So it is very important that the information which is provided is reasonably reliable to attract the user. The second is that information type is also happens. There are a lot of information type which is static information, which will not change with the time. And then there is a dynamic information. So dynamic information is like traffic information, it changes every time, even through the route. But static information means, for example, if you are telling them that there's a restaurant or there's a fuel station on the way, this is a static information which you are providing. Or for bus, you are telling that okay, every 10:20 the bus starts every day from so and so bus terminal. Then it's a kind of a timetable static information. But if you are telling my bus where my bus is likely to come after 5 minutes 30 seconds, then it's a dynamic information. So uh, the quality of the information is a very important when we actually do it. And we should know that, I mean, where the congestion are there and there are recurrent congestions in the area, people use it quite strategically as a journey planner. They plan, they say that okay, I'll start at this particular time, and this happens in Delhi, Mumbai, Chennai. People who travel to the different destination, even on the intercity travel, they plan their journey early mornings, afternoons, so and so forth, to even go to the outside the city, because they know. So they strategically use this information system to make their journey. There may be situations where congestion is very low, for example, in this situation, only when required people use it. If they get stuck on certain things, then only they use that, or which is the shortest path, or they actually forgot the way, or they are not able to find something, then that particular thing actually there. But weather is generally applicable in most of the situation. Like in northern region, the fog is one of the major issues. So if I have travel in the night, then I would like to see that what could be the foggy condition on this, because it impacts the this thing. Drivers which are bit flexible with the routes and the times, for them also this becomes a very important information. So if I have to go at 10 o'clock only and by particular route only, then the information is irrelevant. Whatever happens, I have to go by this fixed route and fixed time. But if I have flexibility that instead of 10 I can go even 12, or I can go start at 8 o'clock, or I can go by A route or B route, or A mode or B mode, then this information is a very useful. Also important thing is that different people prefer different access media. If we say that I have given the information by the mobile app, then it's a wrong understanding. The different users will always have a preference to different media of getting the information. Some people are more comfortable with the smartphones or internet or so on and so forth. Some are more comfortable with the simple text messages and so on and so forth. So the different media to cover the different population is also very important as part of this. Now, traveler information system is also of different types. Now, one of the way we look at is it's called unimodal. Unimodal means, as a highway authority, I say that I am not bothered about what bus is doing or what rail is doing. I want to see my information system or road. So I'll only cover the road part of it, and it can be a unimodal related. I'll give the information of the single mode of this, and there's nothing wrong in this, because many times the multimodal information system also becomes complicated on this. So the each bigger agency, the railways can have their own information system, the highway authority can have their own information system. But if you see, for example, within Google also you go, especially in the larger cities, when you click the journey planning, you say, I want to go from A to B. It tells you you can go by the road and it will take you 30 minutes. You can go by the metro, it will take you 20 minutes. And they give you the fare information, so on and so forth. Now, as soon as you add the modes based on the how complex your system is and how much you are investing on this, then it becomes a multimodal system where you can add as many modes as possible. You can make a real journey planner to the people. So in urban area, this is very common actually. If you see, um, even the regional system like BART in San Francisco, they use 9 to 10 modes in the single journey planner. So they first they give you to door mobility to the people. So car is not the only mode. So by car or two wheeler you can go A to B. They'll tell you the, I mean, route of this most this thing. But if you want to go by public transport, then you can select. If you want to go by the ferry or water route, they'll give you the information. If you want to walk, then they'll give you the information. You want to use a rental car, they'll give you the information. So the information system can be a multimodal too, based on the, I mean, what kind of system is it? A urban traveler information system where multiple modes are available, or it's a regional system where the relevance of this. So when I add the complication in my system, we should be careful that how much usefulness it is increasing on this. In urban system, maybe certain type of journey planning is very important, but in regional system, uh, all those main complication may not be required. So what cities do is that they build the different kind of, I mean, labels in the journey planning, and then they make it modular if you want to actually access that particular thing. So traveler information system, as we discussed, this can be used for the weather, knowing the weather, route guidance and navigation, ride matching and reservation, traveler service and reservation. Now, these third and fourth are actually some of the commercial implication or commercial uses of the traveler information system also there. In fact, what happens is that in some of the places where the traffic started increasing, the authorities also started encouraging the shared riding of this. So, for example, the carpooling of this. So, for example, you might have heard about blah blah, or there are services which started in India also. Now, if I want to put my origin to destination on this, uh, and my car is there, and I am the only one, I have four seats in my car, and I'm going from a place to a place, then uh, sometimes this traveler information system can help you to pool your car or share your car with this. Now, from the authority perspective, this helps you. From user perspective, this helps you. So from authority perspective, you will have less congestion. Instead of two cars, only one car is going. There's less pollution. There's less, I mean, requirement of the petrol or diesel. From user perspective, you're sharing the cost of this. So there are many services which started actually coming in based on this, where they can provide you a information system. They say, okay, you can do the journey planning in my app, and you click the app. Then as soon as you say I'm going from here to here, they'll give you option. You want to share your ride? Okay, only 200 rupees you can share this ride, or these are the people who are interested to go this, and they follow certain process of registering the user, so and so forth, and do that. Also, there are actually people or the agencies who use it for making the reservations of it. Once you are using the mobile apps and all for journey planning, they said, okay, if you want to go by the bus, uh, this is the most efficient. By the car, then you can book a taxi from here and there in this app itself. If you want to go by the bus, you can book that bus itself. You want to go by the train, you can book the train in the system itself. These are the value additions, as I said, did by some of these private agencies, wherein they said that not only the information, but we are also providing you some additional help actually to make your I mean journey more easy. I mean, otherwise you have to go to the counter and book the ticket and so on and so forth. We're giving you the information right here. This is the best mode, and you can book the best mode from here itself. So when this travel and information system emerged with the technology, then the people jumped on it, and then all the private companies came and they started making use of it commercially also. So one can also use this for the commercial use, though from the government sector there are, I mean, not many example where it was done, but a government organization for reserving their services actually do it. So, for example, I am from NCRTC, and NCRTC will have their journey planner, and in that journey planner, they'll tell, okay, origin to destination, you can go by this mode, and in case you want to use this regional rapid transit system, you please click on this, and you can book the ticket. And you can also book the ticket for the last mile. So I'm dropping you, let's say, Sarai Kale Khan, and from there you want to go to INA, so then probably I facilitate you to the metro site also, where you can buy the ticket of metro also. So likewise, there with the information you give them the additional benefits of booking the tickets, getting the information, so on and so forth, which is a value added thing, and then people get more attracted towards that particular thing. Now, as initially I said, there are three important segment of a journey planning or the traveler information system. Uh, what happens is, initially you need information when you are planning your journey. So there's a pre-trip information, there's a on-the-trip information, there's a post-trip information. These are the three parts under which the all journey planners work. And some people in the simplest form, or some agencies, can give you information, I mean, not giving information on post-trip basis also. But generally, I mean, it is believed that if you provide some information on each part of this, you can have most crucial, you feel that, okay, the journey planning only is the most crucial, on the trip is not there. You may still provide some information on the way. Though each part, when you add it, the information requirement increases, and the, I mean, the data and the channels also increases. But if a ideal system we see, then these are the three labels or the three parts under which the traveler information work. That before doing the trip, I should have information of this. Second, on the trip, when I'm going using my car, on the way I use the trip, and the post I use this. So here example is, initially I decided I go by the road. On the route, it gives me information that, okay, in between, if you want to change the route because of congestion, or on the way, or wayside amenities, or this, at the end I again get the information of the parking and various other things on this. So these are the three layers or three components, I would say, of this. Now, in terms of the what type of information, as I said, it can be multimodal trip planning. So initial uh, part, you can know, you can integrate the railway system, bus system, and road system, or you can say no, only the road system. So it can be a multimodal or unimodal information you want to give on the pre-trip. So if it is a unimodal, only the highway traveler information system, road traveler information system, then instead of multi-mode, you will give the information of the different routes of it. Okay, A to B you want to go, then you can take this route by this, so many minutes it will take, by this route so many minutes, and in this route this is happening, in this route that is happening, something like that. It also helps you to kind of navigate and provide the information up to the last point. It will tell you, take left from there, take this roundabout, this much exit, and so on and so forth. So it will help you to give you on route navigation system also. Initially you've selected the route, so the pre-trip journey planning information goes, but navigation is a on the way assistance to you, where it is giving you the all the help of telling you, take left turn from here, exit from here, take right turn from here, so on and so forth. And then the third is the advisory related information of the disruptions, congestion, delay, schedules, and all the related things for this. Now, the content of the information can be of different users, maybe of different, I mean, interests. So, for example, urban commuters and the long distance commuters, uh, one has to do a little bit of study that what is more relevant. The information is a sea actually, and we should not mix up with putting so much information so that people also are actually get mixed up in getting that information. So the most useful information should be prioritized and should be shown on this thing. That's why the most important information are built on this, and then other information are put in different layers if somebody is interested. For example, I'm not interested in car rentals, is that so? Initially the planner will show that, okay, I mean, this is the route, this is the mode, and then it can give you others or something, and then if you are interested, then you can start exploring. So the most important information is related to the traffic, delays, routes, modes. That is what actually people use. Some people also, in certain areas, the weather is most important, accident information, incident information. In urban areas, the traffic becomes more and more important. That in certain places the information of traffic may be less important, where, I mean, the capacity is high, let's say on the expressways and all that. The information only in the traffic may be less relevant, but how, what is the speed limits, how much time saving happens, that is important. Toll is important on this. In the local routes, the information is more dense and more required. I mean, road closures, one-way entries, the truck may require a different information in terms of the entry restrictions, weight restrictions. The car may require different information in terms of the parking, no entries, and so forth. So the information content also changes for urban commuter, long distance, local trips, and also if there's a tourist place, for example. So these are the value added which are done with a localized content of where you are building that. For example, you're making in an area where a lot of tourist spot is there, then you can, I mean, integrate some of the tourist information in the journey planner itself, where you can put a tab in the journey planner. If they are tourists, then they actually click on that and then get more information of the places, I mean, of interest to the national or international travelers. So there can be many content of this, but only caution here is that it has to be decided what is more relevant. Something which is relevant in urban may not be relevant in the intercity. Something which is relevant in New York may not be relevant in India. Or something which is relevant, let's say in the northeast, may not be relevant in northern India. In hilly terrain, the situation may be different compared to the situation which is there in the plain terrain. So everything actually impacts the utility or the importance of what content you are putting and what are the pain points. That's why a quick general study of the user requirements are done whenever these systems are installed in a particular thing. If it is a countrywide or the region wide system, then probably the situation is not that complicated because most of the features are actually inputted as part of this. Now that's how this entire thing is come, that when we design the system, what is the target users? So this is the first question comes in when you all ask some ITS consultant that, "Oh, I want to design a system, a traveler information system." Then the first requirement exists: which are the target users and what are their requirements? So they have to assess it, that which are the pain points which are there on those particular routes and the places. And those pain points, if I don't get any benefit, why will I use the particular system? So the pain areas has to be identified, and which type of target travelers are likely to use that is a very important thing. The second is a travel mode, whether I want to build the uni or the multimodal. So I say no, no, no. But other modes are not relevant. In fact, railway is not there. Buses are very few. So the road is the main mode. Or I say no, I want road itself is very complicated, so I don't want to make it further complication by putting other modes. Or it is a intercity highway where I mean the multiple road networks are there. So and railway is a very sketchy thing, so I don't want to give geographical coverage. The traveler information system can be countrywide, but our country is very large, so it is difficult to have entire countrywide all the information. It can be a city urban area system, it can be an intercity system, it can be urban plus intercity system, it can be a regional system where different system. Eventually when you start going on this, the information content may change, but it can be a national system also. So like Google, you can use anywhere to anywhere, but the content of the information is will be limited to this particular core parameters of this. So the geographical coverage is important. If a government is making a particular traveler information system and kind of integrating it with all their systems, public works department, national highway authority, uh, the contractors, I mean information, the traffic police information. If all this information coming in the single place, you have the toll plaza operator actually giving you information. Then we'll have to identify that what geography we are talking. Are we talking about all national highways, entire country, or in particular northern region we want to give certain information, global national level certain other information. we may not have all the information which is there in a region. The toll operators are very modern in northern India, but less modern, less technology is installed in the some particular northeast or somewhere. So the information content and geographical coverage actually has to be matched, that what information can be gathered where, and in the operation, existing operations, whatever you get is the most useful information, because you are not investing much extra money on that. So that is one kind of categorization. The other categorization is that operators specific traveler information system. So many of you might have observed in your cars, actually you get a navigational system, and this kind of dashboard happens, and then you can access the map. Now you must be wondering what the system is. So there are a lot of private companies who have come up actually in past, I'll say 10-15 years, who provide the private traveler information system, and they have tie up, for example, with Hyundai. If you go, then they have a tie up, let's say, with TomTom. Now TomTom is a company who basically a data company who collect the traffic information, various information. We'll discuss about that. So they can be operator specific traveler information system. They can be a government regional traveler information system, which has nothing, or they can be independent entire area coverage of this. So they can be multiple ways to develop traveler information system in different areas. It is not that only government can develop it. No, it is in fact started more in the private sector, but private sector has a limitations of the information. Government can integrate a lot of information through their own data sets, which are, the information is in any case getting generated. The private company will not have the access to that, especially if you are digging a road, closing a road. All this information actually is, I mean, one way system. You change VIP movement. If you want to integrate all of this, then government has to come out and integrate this information, and then they can do share it with private operator, or don't open the data and use through their own system. That is a question of, I mean, how we want to use or kind of leverage this particular thing. So but it should be very clear that this kind of systems are both possible in the private sector. The information dissemination or information provision has to be done by the various methods. They can be high-tech methods. We call it high-tech now. Probably they are not that high-tech, but then high-tech methods can be CCTV. You can collect information, variable message signs or dynamic message signs. You can provide information. You can collect information or provide information through social media platforms, all the Twitters and all these Facebooks and so on and so forth. Uh, and then there are traditional channels by which you provide information. So even providing a simple information of the road advisory in a newspaper is also a information way to actually provide the information, or by a radio FM providing information is also a way. I mean, but these are very traditional methods. They are there from last 30 years, probably 40 years, probably. By telephone call center, you can provide. So they are traditional ways. They are high tech or emerging ways actually by this. They can be real time information. They can be static information. Real time, as you know, that they can be GPS. We call it location based information system technology, which has changed all this. Google Maps and all this started coming through the GPS only. So which part we want to do it, and I'll specifically discuss one for highway system, one for the Japan which do it, and they are very modern actually. How the highway traveler information system from the within the government sector works in, and how it is done, and we'll discuss one from the private sector also of this. Now source of data can be again multiple types. So is the crowdsourcing data. So crowdsourcing, when I say, the people actually So the data is collected multiple ways. For example, you want to actually subscribe to a one mobile app, let's say Ghana.com. You want to listen to some music or the songs of it. When you actually download this data, this mobile app on your this thing, it will ask certain permissions, and most of us actually allow this permission. Now these people actually collect then the information, uh, so they'll not share the information of your name or the personal thing, but they'll see that you are a entity one, so you are giving a tag, some tag number by which your personal information is kind of generally protected, but your origin and destination and the route actually captured by them. So for example, you are going A to B, then they'll see that what route you are taking and what speed, and this data actually then they sell it to the different operators, and then they make their own information systems, and then they can monetize it also. So large number of now companies has come up who basically monetize their data. They actually take a lot of rights from you, access your travel movement pattern, and then monetize it. So this data then becomes very useful for a lot of these commercial private companies to kind of build such kind of system. That's why if you see on internet, you'll find large number of even startup started using this data and providing to various people. So so the one information is crowdsourcing. From the people you take it, from your GPS device only you take it the information. The second is the traffic transit and enforcement agencies. You take the information, especially in the government side it is done, where you take the information from public works department, the national highway authority, the traffic police, and so on and so forth. All of this data comes to a single platform, then it converts into the information, then goes. There are a lot of taxi operators who also share. So, for example, I was working before joining NCRTC in a company called DIMS. There, we used to track something like 1 lakh vehicle every 10 seconds in Delhi. So all the auto rickshaws, there's a GPS installed. All the taxis, there's a GPS installed. All the fat sevas and maxi cabs and buses, GPS installed. All of this information comes to a control center, and then I'll show you that what kind of uses we have done in the subsequent slides. As I said that we actually have the different types of physical component under which this traveler systems work. So there will be always a central control center where the data will come through the different thing. There will always be a roadside system. So this I'm talking about the proper government-owned system of traveler information, not the what Google does only. That's a partial traveler information system, but a properly made traveler information system will always have a control center. It will have a roadside equipment system. For example, in Google, if you don't have a smartphone, what you do? You are a car driver, or and then you forgot your smartphone at your house. What do you do? So if it is a government driven system and there's a congestion, ideally there will be a variable message sign on the road. So somebody, irrespective of whether you have a smartphone or not, where there will be a diversion point and where there will be a alternate route decision has to be made, you will find a variable message sign saying that okay, there's a vehicle accident on this road, there's a 30 minutes delay. So take left, and if you want to go to this one, bypass this congestion. So there will be a roadside subsystems always to capture the data. You can have the toll systems, you can have the different sensors on this, and then you have a central system. And then there can be a vehicle subsystems by which the vehicle are generally now have the onboard units, and this onboard units actually transmit the data. Many of you, since are from highway agencies, must be knowing that in the tolling now we have the RFID tags available with this. Now RFID tag also has a generate a huge data. But moving forward, if you really see the toll free or I mean the future tolling systems, these future systems actually will not have any toll plaza or any kind of I mean system which will even slow you down. So for example, in Germany they started this almost 15-20 years back, where your journey is actually tracked on their system. So wherever you are going, your car will have a onboard unit and this will be embedded. You can't actually uh, remove this within your system, and then that onboard unit will send your location, and wherever you are traveling, your information on the GIS will be captured. And if that road is a toll road, you will every month get a ticket of so many kilometer toll road with so many I mean rupees you'll have to pay every month. So these systems are also very useful. So on one way it is giving info, I mean collecting the toll, but then on other way it is providing a good information source to you. So the data actually channels are many. Now we are also getting into technology mode. So a lot of our systems are generating this data. They are actually in Delhi, for example, on the border. We have these entry plazas where some tax are collected, and it is through this I mean again through these fast tags and other things. All of this data actually can be used for the multiple things. For example, I am going to Delhi and from Jaipur, and I know that there are queue lengths, huge queue lengths. At one toll plaza there is a 30-minute delay. Then I'll think, boss, can I take the train or whatever? I mean, if it is a too much of traffic jam. But all of that you get through your systems, and it's very difficult for private operator to get the access of this, because you are monitoring at the toll plaza queue length, you have system to generate it. Then the government system can be a very very strong traveler information system. In terms of giving information, it can be information kiosk, in vehicle radio, telephones, computers, uh, dashboard, anything. So there are multiple channels, multiple systems. A typical or I mean traveler information system will have, which will actually which can be done. Um, I think we are now reaching to a break probably.
Yes, sir.
Dheeraj ji?
जी जी
So we break for 10-15 minutes and then again
जी
assemble.
सर हम 50 मिनट का ब्रेक कर लेंगे सर. हम ज्वाइन कर लेंगे कंटिन्यू 11:30 में सर.
11:30.
Yes, sir.
So okay. So we'll then join again at 11:30.
Yeah, thank you, sir.
Thank you. So now next 1 hour we'll be seeing till now mainly we have actually evaluated what are the advantages, what are the systems. Next 1 hour we'll see what system exists. Before that, I just wanted to show some components so that we actually know what we are talking about. So this is one system, and this is same maybe familiar to many of you, that which NHAI also started developing early 2000 time actually, wherein there was a road management center, control center was set up, especially Jaipur Kishangarh and NH48, which was old NH8. All these places, a control center was set up on this. Information was supposed to come from the road, so there's a communication, and there was a some kind of communication link was set up, and this information was supposed to go to the variable message sign, whatever if there's a congestion. In real true sense, how much it was implemented and how much it was used by the users, that has a different kind of places, a different kind of understanding. But this system was set up where variable message signs, CCTV, toll information, toll collection system, uh, with a semi-automatic thing was actually installed in various national highways, and there was a control center. I mean, in most of the highways, you will be finding that. Uh, all of this information can really become a traveler information system, which in true sense, to my knowledge, actually not existing in our network. And this entire thing can create a good information base to National Highway Authority to provide anybody using National Highway to provide a good traveler information system. So in this, there's a control center which is actually providing the information to the user through the variable message sign, and this can be enhanced by providing information through the dashboard and other things on this. So this is one example of this. Then another example is that some of the agencies in last 4-5 years also use the image processing kind of softwares. So the information is gathered through the CCTV, and the processing is not done through the traditional method, but through the now modern method of image processing. So that is another way. So and then the roadside sensors also changed over the time of this. CCTV also became a more I mean advanced over the time. So these are the other equipments which are very useful. Variable message signs, different VMS are there. These are another important component when we develop this. Then communication media, again, I mean, various types. It can be a phone, dashboard, and computer, so and so forth. So these are the example of that. Uh, One example is the FM radio, which is there in most of the vehicles, and then the dashboard and the TV of this. This is related to the SMS and MMS system, by which also one can communicate with this. This is about call center. So in early part, the call centers was one of the important media by which the information to the users was transferred. This is also relevant now, and maybe in future actually there will be a single transport helpline where you can provide all the modes information. Right now helplines are there, but unified are still not there. So all the modes actually through a single number. So there are discussions on the different labels on that. And these are the car navigation system which started in last 10 years. Now most of the cars are having, so it's easy to communicate with them, and internet is another by which. This is a new way actually. In last 4-5 years actually it's more popular by the social media platform also, the information. So you'll find the Facebook page of a particular agency telling that, oh, we are doing maintenance and please avoid this particular route and this time to this time. Or if you actually subscribe to them, then you get the triggers messages on the route you go every day, or frequently of this. So these are the another channels by which we generally do. The customers are multiple. Which area we are talking, it depends on that. So in urban, auto drivers, passengers, the car drivers, the paratransit, we call all these Fat Sevas and the Vikram tempos, bicycle riders, even pedestrian, freight carriers, truck walas. All of these people are actually the users of this system. Then the fleet managers, I mean the freight fleet thing, the bus operators, all of these are this thing. Then police, ambulances, the emergency vehicles, the agencies itself who are managing the traffic management center. So in India we don't have real traffic management center, though in big cities like Delhi we have the traffic police control center. But if you go to the bigger cities like New York and all, or even Tokyo, you'll find a large centers. Like I was in Brazil 2015, and Brazil built the one of the largest control center because they faced some problem in 2012. After that, they built one of the largest control center for traffic management and weather related traffic congestion, and it has all the information which is actually given to the users if you want to. So the agencies also use this information for better traffic management. If there's a traffic jam on a particular corridor, then they change the traffic signal timing from the control center itself. So this is very common, especially in the North American cities, that you really, I mean, manage your highway and the city's network through the control center and move the traffic more, I mean, smoothly. This. So let's now try to see the some examples of this. So first, let's see the public transport related thing. So we'll discuss in detail the road related, but then we should also know what other systems are there. So briefly, I have tried to incorporate the public transport information system also, because in the multimodal traveler information system this also becomes important. So even if highway agency is building their own system, at some point of time in future there will be a multimodal system. That's why we should know what we are talking about, the other mode. So traveler information system for transit means the public transport system relates to the buses, the railways, the metro rails, the ferries, the rapid rail, so and so forth. And this information can be static information, means the route information by the bus route marked by a simple line. So it's a static information. Timetable means the bus start at 10 o'clock, 11 o'clock, 12 o'clock. But if the bus is delayed, there's no information available. So static information is that the paper information which they are supposed to follow. But what is happening real time, that is another information set. So if the bus is with the GPS, then we provide the right information that where is your bus right now. It is going to come after 4 minutes. So in metro you might have seen that they have a display on the station. They say the metro coming in 4 minutes, 3 minutes. It follows that. That's a dynamic information. So in transit, that is important. Now this is a one example I'm showing which is already implemented in Delhi for the transit. So this was implemented by the Delhi Integrated Multimodal Transit System Limited. This is a 50% government company, where this mobile app on the Delhi bus system was created. And in this mobile app, you can actually plan your journey. So you can see on plan a trip is written on this. So you can put from where you want to go, where you want to go. Then it will tell you these are the bus routes which will take you. It will it also tell you this is the bus stop, this bus route will be available. It will also tell you where your bus is. So it can tell you the bus will arrive in 12 minutes. It will also tell you that how crowded the bus will be there, or whether there will be seat availability or not. So all of this was done. In fact, this app was launched in 2012 itself, and then now we have One Delhi app, which should probably have more information. This is the photograph of the control center which was set up in this company. So this is actually actual photograph of the control center which was set up in Kashmiri Gate ISBT, Interstate Bus Terminal Complex. This was set up, and all the data was coming to this control center, and then it was actually transmitted through this control center to the users through this mobile app. So this was a mobile app, and as I said, all the buses, all the auto rickshaws, all the taxis, and this paratransit vehicle like the Fatfat Seva, Maxi Seva, all were fitted with GPS, and the data was coming to this control center for almost 1 lakh vehicle every 10 seconds. This data was then going to multiple channels. So in terms of channel, one is a mobile app, second is the internet, and third, you on the right hand side you can see the bus stop. So there were some 200 bus stops where this information was also put in on the bus stop through the variable message sign. So you can see there are some numbers that it says that route number, so bus is coming in 7 minutes or something like that. So the information channel of the transit is the bus stop. At bus stop you get the information, or at your house you get, or on the way you get through the mobile app in this. So this is one example of the transit. Within transit, there are paratransit all. Paratransit means auto rickshaws, taxis, and so on and so forth. For that also, there was a one additional feature was developed in this journey planning, in which if you tap it, this is as old as 2012, 13. Now these things are available in many other apps also. But this information basically was telling you that if there's a auto rickshaw available within 300-meter from your place, then you will get the phone number of that auto rickshaw, and then you can call it, and it was freely available. Now Ola and Uber also created this later. After this was the first step which actually started giving this information. Then we also integrated at that time the parking information. So NDMC area was under the DIMS itself, and there was a lot of data was coming. So in the same app, you can see where the parking is available in Connaught Place, and how many spaces are vacant there, and what is the parking fee there. So that data was also integrated. So the user, if they want to go and use this, they can know which route to take. Then they can know where to park their vehicle and how much they will have to pay. Likewise, if they want to go by auto rickshaw, they can click this, and then they'll get a phone number of auto rickshaw. They can call the auto rickshaw, and then they can pay. They, in fact, they can see the distance, because they, if they have some problem with the meter of the auto rickshaw because there is some problem of overcharging, then it will also give you the parallel distance in your mobile app. So this was one example of the transit system traveler information, which is now available in most of the cities, big cities. In any case, is available, and this was created in Delhi also. It's available in Mumbai and various other places of this. This is for paratransit, as I said. For these are the auto rickshaws, and these are the Gramin Sevas, and so on and so forth. This is the photograph of the uh, of that control center which was set up at that point of time, and you can see the basically um, various delegations actually visiting and inaugurating this control center. So this was about the transit. Now we come to the highway information system, which will be more point of interest for all of you people. So highway information system, we will start from the past, how it evolved. So the originally the highway information system and the technology was not that advanced. It was more of a calling certain number, phone number, and then getting the information, or through the FM or radio channel. That time FM was also not there, so some of the frequency was allocated to certain this thing. So the original way of, I'm talking about 30, 40 years, and especially in the US, this is how this system started to give the national travel helpline number, which was created 511, and this is how it was put in on the highways and used with this thing. So this was the first this thing. Then there was highway stations started. So with the FM and the normal radio, there were some frequencies actually which were allocated to them. And entire, I mean, Europe, multiple countries had this kind of a highway radios which were assisting the highway travelers by the various information on the weather, on the congestion, and so on and so forth. And that was the main mode of communicating with them. Then, with the time, actually, the technology changed, and now you can see that we have the simple navigational system like Google Maps. Now, Google Maps, you can get the information on the routes, speeds, time, delays, and also some additional information on the toll, whether there's a toll or not. This thing, but this is called a simple information system, which is very useful, but it is not providing all the information of this. So this is another, I mean, a system which is used very frequently for the highway. And Google Map is integrated with the dashboards through mobile phones and so on and so forth. Now, one information system on the highway should not only have the information of the traffic, but it should also have the other information on this. And that is how the right information system actually happens. And you'll see how the future is changing, and you'll realize that the future of the traveler information system is very different than what right now we are doing. So the past was very primitive. Now we feel that it was very basic. Even the future will, when we reach to the future, we'll find these systems are very primitive and very simple. This, but today, sense also, if we see, the information of the traffic is one of the information. Other information of the incidences, the road works, the other divergence related are also very important, and these are important from user perspective and authority perspective. Authority also, if there's an accident and large number of people are coming there and creating a traffic jam, it's a problem to manage that site. So they also have to kind of see that the traffic management, or at the management at the toll plazas, whatever facilities they are having is also managed through the different information to this. So this is how I mean, the first information works. So basically, the information is collected from the road, and then it is given back to the users. And this is done by the road agencies, police, and weather agencies, and all related departments. They all share their data to the control center on this thing. Generally, loop detectors, floating car data, video cameras, toll plaza, weather stations, all of this collect the data, and then processing of the speed, fog, visibility, all of this, and then give the information to the people how much congestion, and even the predictions can be done on this. So these systems, the main systems are CCTV. These are traditional systems I am talking, which in fact NHAI has installed in most of their highways in past, and even probably in future they'll continue to do. But we'll see that how the future is changing with the time. So this is the CCTV, one of the thing, one of the component. Then variable message sign. So CCTV, you, for example, put CCTV at strategic other than this. This is another equipment which is a weather station. So meteorological data actually is collected through that and then put in. This is more, for example, northern India, especially the foggy days, the rain, if there's a flooding, especially on our highways. If I talk about NH48 on the service road, uh, if there's a heavy rains, then there will be water on this. So people should be informed that okay, avoid this service road, rather take the U-turn from here there, All of that is required. The many times actually we ourselves got stuck in that because there was no information. There was a rain, and then there was a water on the side service roads, and we got stuck because we have to take the right turn through the service road, and there's a huge water, and then there were huge traffic jam, and then vehicle got, I mean, within the water thing, and people were having. So if the information is there, they will not get in the service road itself. They'll take the U-turn on the top of the highway, and the main highway, maybe traveling 20 kilometer and then taking the U-turn. So this is how this all information is held. This was the control center way back in 2005 actually, when I think this is one of probably this old NH8 control center. I since worked on that time, I had one photograph. So this is how it looked actually in those times. And these are some of the equipments of this. So these are the list of the total equipment. Now this project, there was a one, it's called HTMS project, which was actually done 4-5 years back on Noida, Greater Noida Expressway. This system was put in, highway traffic management system was put in which the traveler information system was also part of it. So in this system, they have put in CCTV surveillance system, variable message sign, speed monitoring, ANPR cameras. ANPR are basically which captures your registration plate automatically. So they'll take the photograph of your registration plate, and then it will connect with the Vahan database. So it can actually recognize who's the user, what is the address. So ANPR cameras were put in, speed monitoring cameras. Video detection system was also put in, which was first time. Video detection system means there's a CCTV, and then there will be software which will see the changes in the pixel. For example, there's a fire on a particular part, and there's a CCTV or video is there. Then the software will capture that photograph, and then it will see the pixel, and it will compare with the normal with the fire, and it will actually run a alarm system which will go to the control center and the emergency center, where one can really further analyze and send the whatever, I mean, rescue is required, or I mean, ambulance is required, fire tender is required. So this video incident detection system was put in, then weather monitoring system, and then control center through the OFC network was there. And the information was actually given back through the variable message sign, mobile apps, and various channels like even the website. So these are some of the projects which were actually implemented. So on national highways, when we implement this highway traffic management system, one of the important part of the highway traffic management system is to inform the users about the anything which is unusual happening on our road. If it is a rain and there's a problem of the flooding, we should inform. If there's a fog, we have to inform. If there's an accident, we have to inform. If there's a congestion, we have to inform. So the main purpose of highway traffic management system was to inform. That will help the facility management of the National Highway Authority roads, and it will help the user to not delay their journey and not get frustrated, and so on and so forth. Uh, these are some of the photographs, this thing of this Noida Expressway thing, wherein if a vehicle is coming, so there were different things were actually inputted in that software. So if a vehicle is traveling, for example, in wrong direction, then the detection technology will take it and inform the control center that the vehicle in opposite direction. It's very important from the safety perspective. So the nearest officer will go and try to challan him. If there's a speed drop, if there's a congestion, then which means there's a speed drop. It will capture the video system will capture the speed drop, and if it is continuous, then it will say there's a congestion here. If there's a fire there, then it will. If there's a queue, it will control the queue. This thing. So these systems are much superior than the what Google provides. Google is only dependent on one type of information from the user. But the only problem is that managing and maintaining these systems in the setup, actually that business plan is still not evolved in our country. So while we put in a lot of equipments and a lot of investment, but still the maintenance of an operation of these systems, there has to be a business model evolved so that the equipments are changed, maintained properly, and the data is also uh, provided properly, and there should be a monetization mechanism also, so that, I mean, there's no undue um, burden of the financial on the agency. So that is, I think, still in India work in progress. The second system I wanted to discuss is the private operators offering. So it's called a TomTom Traveler Information System. TomTom is one of the companies who basically provide their traveler information system to car agencies. So many of the cars like Hyundai and some more actually integrate their system directly. You don't need Google there. They have their own system. So these people are the private, and they monetize this data, and they collect the data also. So some data they collect from the cars which they have already installed the system. So car is getting the information and giving the information. This is the beauty of these systems, that if my car is getting the information coming of the car which is ahead of me, and I am giving the information to the car behind me. So each one complement each other. So one part is that they get information from the users itself. The second is they collect themselves also. So they actually put in their own cars, which is called probe cars. So they keep traveling on the various network and collecting the information. They have some equipment installed on those cars, and these are the real time dashboard which changes with this. But the information type is only basic. So mainly the traffic jam, and they also have some algorithm to predict it based on the historical trends, that okay, how it's going to behave in the next 1 hour or next 2 hours. They give you some prediction also, and they also give some historical traffic analysis for this. So the agencies, government agencies, many times can utilize their data. We did in multiple occasions by partnering with them to understand how the traffic actually is building up on our road, which are the times where the congestion happens, which are the spots where the congestion happens. All of this data is very important if you really want to make your road efficient. So if you know that this spot actually is having recurrent congestion, or this spot is having once in a while congestion. So once you know that there are 5 points where every second day there's a congestion, then you'll start doing something. You'll say, okay, because why there's a congestion, and all of this actually information comes through their historical data, and it is used very extensively by various agencies outside our country. In our country, authorities are very little using. Some in bigger cities may be little bit using, but then that has to be used for better traffic management on this. This one snapshot which they cover for. So for Delhi, actually, I picked up. So these are their probe cars from where they are getting the data. So many locations they are getting the data, and from this data then they are giving the information like this, which is you can relate with the similar type what Google actually provides you, that what is the congestion, but they give you additional information of certain uh, things actually. uh, I mean, if you want to take their private this thing subscription and all, they can give you personalized information also, because they are the private companies on this. So they also issue in general public the various kind of reports, weather related reports. This particular time, don't use this particular expressway or highway or this, because there's a fog in this particular time. Traffic jam predictions they do. This spot actually every day between 6 to 9 there's a traffic jam on this. So they take years and years of data and try to develop some algorithm, and then try to tell the users and the authorities on this. We utilize the data in one of the studies, impact study we did for Delhi government. It's called odd and even steady impact of odd even. So if you recall, in the winter, government actually decided to do this odd even schemes where one day only odd number plate vehicle allowed, another day only even number plate allowed. So they asked us to, I mean, evaluate what was the impact on traffic congestion, pollution, and so on and so forth. So we took this data, digital data, which is the most useful data actually to analyze. So authorities can actually see if this data is very useful for strategic decision making on this thing. They also give route information, which you are familiar. I mean, in terms of the Google, also they provide the similar kind of thing. So these are some of their snapshot of the different locations. They are saying that okay, average speed should be so much, but then right now the speed is so much, something like that. And different places they give information. They give some kind of reports, live reports, and the I mean weather forecast and so on and so forth to assist the users of this thing. They also release some reports by which they say that okay, which are the days which are worst in terms of the traffic. So they call tom traffic index, and they say that which is the time which is the most congested time in particular days. So congested days, congested times, congested roads. Likewise, they actually try to tell congested cities. They say this city is the most congested in India. This city is second most congested. How much time lost by this? This create pressure on the agencies to kind of do more better traffic management thing. So they kind of try to report as a pillar, I mean, a communication pillar, by saying that see, these are the areas which require more kind of I mean attention by the local agencies by this. uh, Now this is about the Google. So Google, all of you must be using. So this is a parallel system. So TomTom is one of the operator, but Google is another big operator which takes the data mainly from the crowdsource. And also Google started taking some data from the government agencies websites and whatever is available in public domain, and they start giving all of that information to this. Now, if we compare with TomTom and Google, you'll find most of this information actually is provided by both the agencies. So TomTom, Google, they are all, I mean, from the private sector, which provides a basic traveler information system to the user. And it's very useful, at least for the people in bigger cities where traffic jams are frequent. It's a very, very important thing. But from the government side, the use of this is very little. A little bit used. Traffic police sometime is doing in some of the cities. Now there are some awareness where people are doing some kind of tie up with these operators and kind of using it for uh, uh, decision making on the various things. Now, this is another one which is the most important and most modern, I would say. It's called Vehicle Information Communication System, Japan. And Japan has been one of the, I would say, most advanced in terms of using the ITS. So the early part of evolving the ITS started from there. So I picked up this VIX system to give you a perspective that how the Japan gives the information to their users and how it is evolving. And this is a government system. This is not some private operator taking this. This is a very structured government system where they have a control center, they have roadside equipments, and it is actually emerging over the time. They have a different system for highways, different for local roads, so on and so forth. So it's a very innovative system, and over the years it has actually evolved. They keep actually upgrading it. You can see this, that there's a control center, which is a very modern control center with a lot of equipments on this. So this diagram indicate that there are three types of uh, I mean information channels they utilize. The one where it is written, it is through the FM. So they still use the FM, and FM is used in a wide area. Now FM has a very wide area. So FM, by FM they keep giving information to the users that this is happening, that is happening. There's a congestion here, there's a congestion there. and they are specific FM channels which actually provide the information for different area. The second is the infrared beacons. Now these are the roadside equipment which they use infrared and the radio wave. Now infrared has basically some limited application, certain speeds and the certain range. So in the second category of the roads, especially let's say in our case, we can say we want to go to MDRs or state highways, then I'll use the infrared beacons. Or if the road is fast and wide and importance wise, then I'll use the radio wave roadside equipments, and I mean the equipment to put the information. So they use mainly three types of information channels. One is the FM, second is infrared for the local roads or secondary roads, and then radio wave based systems for the primary roads. And these is one part of it. Then they, if you see on the bottom, they use different types of channels. So they different types of information giving to the user. So text based information, graphical information, and a good map based information. All these three they provide. How this works? So the principles are same as we discussed earlier. First, they collect the information, and they collect not only information from the roadside which they have put in, but they take from the road administrators, traffic, road traffic information center, get the information from various types of systems like meteorological data centers, roadworks departments, and so on and so forth. So all of this data actually in the government system comes in, and then there is a VIX center where this is processed, and then this data goes to either FM channel or the radio wave. It is transmitted to these roadside equipments, and any vehicle which is passing through this roadside equipments, they will get that information in their information display. So there is a dashboard in most of the cars. 99.9% cars in Japan are having these dashboards from a long time. So you have an onboard system. So this, as soon as you cross this particular roadside equipment, the information is fed into your system. So on your dashboard, the information will be available. How they show it? They show it by arrows, very simple arrows. That if there's a heavy congestion, they'll show red arrows, orange arrows, green arrows. Then they will show the information of the accidents, disabled vehicle, construction site, icy roads, work operations, traffic obstruction, and even the one ways and entry restrictions, load restrictions, so on and so forth. So they have integrated actually the various agencies data in their setup, and they provide dynamically to this. You can see these information, that what all kind of information. So for example, if there's a parking lot which is empty, you'll get this P with the blue one. Parking lot which is congested, the surrounding roads are congested, then you'll get this orange one. Parking lot which is full, you get the red one. Parking lot which is closed, parking lot unknown. All these symbols they use actually to give you information. Then another way, you can see the symbols of the speed limits. You can see the regulation of the lane. In Japan, you have a regulation of the lane. For example, on the shoulder is not used by the vehicles until unless they are authorized. Shoulder will be used only for the non-motorized or for the stalled vehicle. So if you are on the shoulder using shoulder as a normal driving, you can be challenged likewise. So and then they are ramp metering basically done. Ramp metering means on the expressway, when you are having a ramp, that ramp is controlled. So if there's a congestion on the expressway, they stop the traffic on the entry ramps. I mean information that which ramp is open, which ramp is closed, all of that, where one way traffic, two way traffic. So you can compare this with what Google or TomTom is providing. this information is much more rich actually compared to what they are providing. Now, many of this information may be more relevant in the urban area. So wherever it is relevant, they provide. Some information is relevant in intercity highways, like there's accident, they'll provide. If there's a lane closure, they'll provide. Or if there's a parking lot, they'll provide. And some is more relevant. For example, a speed limit also they'll show on the dashboard. This is the speed limit. And now with the system they have integrated, you can get the alarms and all that if you are exceeding that particular speed limits on this. Now this is a kind of a, I mean, three channels by which they provide. So one is the text. So you'll get some text written that, okay, uh, I mean, there's congestion ahead or something like that. Graphical is labeled too. So first is text. Even if you don't have a smartphone, you can subscribe to it and you'll get the text in your system, whatever. I mean, they, since they have a onboard systems, then it will just push to the text. So it will just say the congestion ahead or slow down or whatever. And graphical is basically, as I showed you, the arrows. So different arrows or the symbols only are displayed on this, on the different this thing. So that is the second label. And third is a proper map on which they show the information. Everything is shown on the proper map. And for map also they have a different types of the map available. Very simple map to a very high level maps actually they utilize for this. So these are some examples of text messaging in Japan they do. These are some of the examples of the symbols they utilize actually to give the information. And this is the example of the map. In this map you can see that there's a parking symbols are available. They are work on the road symbols are there. So there are arrows, there are different kind of thing. Roadblock symbol is there, accident symbol is there, one way symbol is there, work operation symbol is there, disabled vehicle, lane regulation, traffic obstruction, construction site, empty ramp closed, parking lots. You can see that 15 types of information and can compare it with what Google Map provides. You will not get this Google Map, and neither they have the information of this. So the point which I am trying to make is that traveler information. Many people get confused with the traveler information system uh, as a Google Maps on the Google Map is a one part or one bit of the advanced traveler information system is there, both from the user and the agency perspective. But if the agency, government agency is building it, then they can have the possibility of providing a lot of information and also using themselves that information for the better traffic management of this thing. So that is how. Now the beauty of this is that they are upgrading their systems. I mean, it's in existence from last 30 40 years. Then they made it Wix wide. So when the technology started developing further, they said, okay, we also upgrade on this. So they released a new service called Wix wide. So in Wix wide, nothing is there. I mean, more, you have more channels, more ranges. Earlier you were getting information of 100 kilometer from where you are. Now you can go up to 1000 kilometer likewise. So for example, if you see the FM, they increase the FM broadcasting ranges of this. Radio waves base system was installed on expressway and it was covering 1000 kilometer in the direction of travel. Means you'll get all the information of 1000 kilometer from where you are where you are right now is there. So up to 1000 kilometer you will get all the information of the expressway, travel time, disruption, interruption, interchanges, regulations, so on and so forth on this. And on the ordinary road, which is I understand are the secondary roads, you'll get the information up to 30 kilometers from the where you are getting this. And these are based on the infrared related equipment. So since the investment and the traffic labels are also different on different roads, they have actually designed the system differently for different things. So this is basically showing the area on which the FM you'll get it. And they have a specific channels available on which you only the traffic related information is put in on this thing. Roadside equipment, if you see, this is a roadside equipment where you can see the radio wave based uh, uh, receiver or transponder is actually put in, and it interact with the car. So as soon as the car actually pass through within that range of 20 meter, they exchange the information. The car will give the information to the radio reader, and the radio reader will send the information to the car. So both actually exchange the information. So the car will it will pick the information from different beacons, the way the car earlier where this car was there, so it will calculate the speeds within that time, and then it will also give the information which the other car has provided, which is ahead of it, because these equipments are there on the different places in the network. So this information gathering and then giving back actually is used through the roadside equipment in the traditional system of the VIX. This is again for the secondary road. Secondary road, these are the relatively less range system, where earlier you find 20-meter range, here it's only 3.5-meter range, and these are actually captured on a lower speed relatively on this. So the information uplink and downlink, you can see some information goes back, some information is given back to the users. So these are some of the information on the expressways given, on ordinary roads given. Uh, this is how it looks like. So the information I mean, after the VIX was deployed, they do this monitoring of this. That I mean, when the system was done, how much saving they have done in terms of the, in terms of the money. So they have estimated that, I mean, the socioeconomic benefits of VIX is very high, because they have actually saved some 12%, or you can see 100 billion yens due to the congestion they have saved by deploying this system, because people are not getting in the jams. So they actually justify this investment through the benefits associated with this, and they do this continuous study based on the data and then present to them, and then the funding is only given when there's a substantial benefit of that particular technology on this thing. These are some of the examples that how heavy rain areas they actually integrated. They pop up the emergency warning if there's some problem, fire in the vehicle ahead of this. There will be a pop-up message on your dashboard, detailed traffic information, travel time. All of this they actually provide of this. This is the dashboard which they use, and they are in vehicle equipments also. You can see each vehicle will have FM radio antenna, which will be integrated with the highway radio, and then they have the dashboard navigator, car navigator, and then there's a equipment called beacon receiver, which will give the information and take the information from the roadside equipment. And all the cars like we have onboard units, these are all generally mandatory requirement on this thing. This is their information booklet from where I actually picked it up. You can see all the information on the bottom side. You can see how they have a symbols designed to put on the map to put more information to the user, and then once you start clicking those symbols, you can get more information about that. And all of that is integrated for the text, for the simple graphic display, and the map system, which are the three labels on which they give. These are the control center. This is from very basic system long back, 30, 40 years back, to a very modern system. Actually, now they have this, and they use different technologies. This, and one of the reason is that the requirement of I mean our particular road. So the high end requirement of the expressway, they have a different system than an ordinary trunk road, which means that they are not making high investment in the smaller roads. They are saying, if my requirement is small, I have a different system for them, basic system for them, which is less costly. And if I have a more requirement on expressway, I have a better system for you. Now in 2020, they now started further upgrading. So Wix wide was a, I think before 2020, 2015 and all, they started. Now they have actually started putting the system, which is a prop based system. So they were actually running little behind than Google and these people in terms of giving information, because their information gathering was only through the roadside equipment. But then the GPS technology and all that came. So now they have integrated their system. So now they are more robust than any of the, even the traffic information system. So they get the data from the GPS as well as now roadside equipments. So all the roadside equipments they have integrated, plus they have this probe data through the GPS. So you get the most accurate information in all parts of the highways. In Google, TomTom, you may find no information in certain part, or you may find that a smaller road, it will take you, won't give you the right information. But they have a very authentic information through the multiple source which they integrate and then provide you this. And this is very recent, 2 3 years back they started integrating this data to make their system more accurate. uh, and information terminals they put in, if you are going to some restaurant to somewhere, you'll find this kind of information kiosk available everywhere in the cities and even on the highways, where you can really see, click, see where you want to go. You can do journey planning, you can know the traffic situation, so and so forth. Many of this information now become less efficient or less usable, because people have smartphones, so they will use their own smartphone on this. And this is about the weather system also. They have included, they have included the vehicle restriction, route restriction, incident management, weather management. All of this they have integrated as part of their system. So this was all about what is happening now, till now. So we saw the past, we saw the present. Now what is about the future? How the technology is changing in terms of the information system. In past, we were happy with the FM radios, or some phone-based call centers, to the this kind of map-based system. Will this continue as a what we are right now seeing? Let's try to see what is happening in this, in terms of the technology deployment. Now in technology deployment, there are multiple things are happening. One is that in vehicle communication systems are coming. These vehicle communication system interact with the driver, so that's the one part which is evolving. Already this is in place. Then there is second, vehicle to vehicle communication system, which are under trial now. In most of the developed countries, they are in the advanced stages of trial. So it's called vehicle to vehicle communication system, vehicle to infrastructure communication system, and vehicle to everything communication system. These are the four labels, out of which the first in vehicle communication system already is in place in most of the higher end cars, where the vehicle will communicate with you. But other three systems, they are in advanced stages of trial, and the trials are very successful. And in future time, they are going to come and change the way we actually travel in our this thing. So let's understand what it means to us. So let's see, how they communicate, what they communicate, and so on and so forth. So the first is that what we have on the road. So on the road we have the multiple things. So on road, for example, we have the marking, let's say road markings are there. So most of you know that the road marking has a specific purpose. So you say, okay, I want to enable the lane driving on my highway, and if somebody is actually changing the lane again and again, it actually disrupt the capacity of it. I mean, the lane changing is very unsafe also, and people have to be disciplined on this. Now, if you want to enforce this, what is the tool available right now? You want to tell the driver that you are changing lane too frequently, and if you continue with this, you'll meet with accident or I'll challan you. In that situation, one is that you have to provide the information. So these new technologies, what they're doing is that road information, what is there on the road, they're talking to each other. So the car is talking to the road, and it's telling, so at your dashboard, it is actually telling you that, okay, now you can change the, you can overtake the vehicle, you can change the lane. It is telling you that, okay, now the traffic signal is coming and it is red. So rather than you actually jumping out your head from the car, on the dashboard itself you can see the traffic signal, because it is speaking with your car dashboard. It is showing, like in metro rail or in these things, the driver will have on their dashboard the green signal, red signal. Likewise, the infrastructure on the roadside will speak with the cars or the buses or whatever road vehicle is there, and on their dashboard itself they will see that there's a signage of a stop sign is there on the dashboard. And if you are not still stopping, then it will pop you up. It will actually speak that please stop, because there's this thing, and if you don't stop, then you will be challenged 1000 rupees, something like that. So now the future is that the vehicles will be starting talking to infrastructure, and also with the vehicles. The vehicle behind you, vehicle front of you will start providing the information to you, because each vehicle is a source of information. Earlier it was going to, I mean, equipment, roadside equipment, to somewhere. Now this technology actually is becoming more smarter, where they start telling you on infrastructure level different things, right there on this thing. So let's see what it means to us. So for example, we have the lane marking, road signs, traffic lights. Now these has to become smart. So now if you google it, that smart lane marking, so you'll find that there are smart lane markings available which can speak to the vehicle, and they will have the chip embedded and so forth, and that chip will tell the vehicles that this is the marking. Signage will be the smart. Now you just put a one IRC, you take the IRC and then install a signage. These are traditional signage. The future signage will be the electronic signage only, and they will start speaking. So rather than you searching for the signs where the sign is, you will be basically getting the information within your vehicle, within your dashboard, where the sign will say you are entering now no entry road, rather than you searching that which is the no entry road for this thing. So all the traffic signage, lane marking, traffic light, all of this actually in the future are going to become the smart. And this is not something which we are just talking and I mean imaging that okay, this is going to happen. This is already in a reasonably advanced stages of development, and maybe next few years you'll start seeing in all developing countries, because the trials are in a very advanced stage. So let's see. I mean, this is one example which I just wanted to show, where the traffic signal is speaking with the car and then giving you the information of the onboard unit of the car. So there's a smart roadside unit in terms of the traffic signal. It has not only the traffic signal but multiple other things which takes the information, gives the information. So that is a vehicle to infrastructure communication, by which both the vehicle and the infrastructure will speak to each other. If you are, for example, you have a stop line at the signal, the stop line will speak with the vehicle by saying that you are actually, you have crossed the stop line, red line, on the intersection, and you may be challenged for 500 rupees. Now Right now, you'll have to see that where the line is there and so on and so forth. These will be electronically actually put in on this, and they will have the chips and various things, and there will be monitoring system on the top, and it will communicate with you. The CCTV will capture that, okay, whether you have crossed it, or there will be chip on this which will actually take that. So all the equipments on the road, all the infrastructure of the road is now gearing up to become more smarter, which will start speaking with now the vehicles and start communicating and giving the information, taking the information. And the purpose is the first one, as I said, improving the road safety, improving the traffic management, improving the convenience of the users, and improving the traffic management practices from the authority. This thing. Now, these are also some examples of lane changing between the vehicles, or there are some obstacles. For example, somebody is crossing the road and so on and so forth. All of this actually can be will be the part of this vehicle to infrastructure communication on this thing. These are another example in which basically there will be advanced road marking, there will be smart signs, and then wireless communication, which is now under testing and trial on this thing. Now, vehicle to vehicle is another communication system which is very fast developing. In vehicle to vehicle, what happens is we saw vehicle to infrastructure, which is signage, which is the this. Vehicle to vehicle means the vehicle ahead of me or vehicle behind me are also speaking to each other. So I saw that there's a traffic jam actually ahead of me, or I saw a accident, or I saw that the vehicle in front of me is actually slowing down. So I gather this information, pass on to all the people behind me, so that they become caution. Somebody who is coming at 100 km per hour speed behind, if he get the information in a foggy condition that there's an object on the road, the half of your accident on the expressway in the winter will be actually vanished. So it's a extremely important information, where the one vehicle captured one information and then passes on to the vehicle on this. You can see this particular chart where you can see the different vehicles. The front vehicle blue on the downside, you can see that one vehicle is gathering the information and passing this information to the other. So there's a stop vehicle, there's a fog on the below you. If you see, there's a fog written, and then there's a stop vehicle written. Now the first car which is actually reaching to this is also a smart car, and it is finding that there's a problem and there's a possibility of having accident. So it is informing, because you have a lane driving all the cars in that particular lane, that there's a vehicle on this and you please change the lane, slow down, otherwise there will be accident on this. So the vehicle actually speaks on the vehicle and provide the information on this. uh, this is another example of vehicle to vehicle communication. And also vehicle to pedestrian information. I mean, the objects, whatever form it is there, I mean, you get to know that why people are crossing the road and so on and so forth. If it is a pedestrian way, then they detect, the sensor detect that there's a presence of the something on this, and it communicates with it. So vehicle infrastructure, vehicle is a very very emerging technology which is going to change the way we look the traveler information system. Um, uh, I mean today, this is another example where it's telling that incident ahead, reduce speed, move to the left lane. Um, this is another example. And the vehicle is getting the information of this. There's another new emerging technology which is called mobility as service, or MaaS. MaaS is a very emerging technology, and I just wanted to spend 1 minute actually, so that you are aware about this all emerging technology. What is happening is that today there's a you are owning a car, but just imagine tomorrow if some company comes to your house and tells you that I will take care of all the requirement of your family, of all the travel need. If you want taxi, taxi will be available. You want Mercedes taxi, it will be available. You want metro, metro cards, I'll provide you. If you want rapid rail card, mainline rail card, they will give you the bundled solution of mobility as service. They'll say that okay, you give me 10,000 rupees a month, and I'll take care of your travel need up to the office or wherever you go, your daughter's need of going to the college, your son's need to going to the office, your wife's need for going to the shopping, and this thing, and I'll only charge this, and I'll provide you vehicle of your choice and this thing. Will you buy a vehicle? You'll say, oh, why should I buy a vehicle? If there's a headache, I mean, for the accident, for insurance, for parking, and so on and so forth. This is how the mobility as service is changing the vehicle ownership pattern, especially in the Europe. This is in a very advanced stage. In India, we are doing some level of integration. So the future of the mobility is as a service, not as a ownership. Right now, we own the car. So the emerging technology is that in the future, probably the car ownership actually goes down. And my car, I use only 20, 30, 40 kilometer a day. But if it is a car owned by a mobility as service operator, they use 200 kilometers. So the asset utilization is there, the cost per kilometer is there. So this is an emerging technology which is coming up. Next few years you'll find a major impact of this in the entire traffic and information system. There's another very important thing which is emerging is the in-vehicle information system, and many of you who own relatively, I mean, costly cars, it's already there. For example, if you don't put your seat belt, you'll get this beep which will tell you, I mean, that you have not put in the seat belt. Now, this system is enhanced. If you are drowsy, there are systems actually which will actually sense you that you need actually a break while traveling on this thing. So now there are in vehicle system which provides you the warnings and the information and interact with you to make your journey safe. And this is in modern cars are actually increasing and increasing become important. If you are exceeding a particular speed limits, and there's, I mean, the vehicle is actually indicating that okay, you are exceeding it, so it will warn you beyond that, whatever, I mean, speed limits are set by, I mean, let's say for a kid by the parent or the agency for a particular road like this. Within this information system, there's one more new development in which there are some private companies who evaluate the drivers based on his driving pattern, and they put a small OBD or onboard unit by which your driving habits actually are identified. If you can be a good driver, bad driver, you are ranked actually as per this. How it benefits you? Your insurance bill actually reduces by this. So for example, you go to the car companies and your insurance company want to buy the insurance for this. If you are a good driver in the A category driver, you'll get 25% discount. Likewise, so there are many companies who actually promote, and they promote in social media, tell you that how good driver you are, this, and also it helps you and this, and how much money you saved, how by fuel saving. If you are average running your car at 50 kilometer, then how much money or fuel you have saved, because the car, if you are on either very slow or very high, then it consumes more petrol, more diesel on this thing. So they give you more information. How many times you have put in the brake, they will give you that information, due to which how much fuel you have lost on this thing, that information they give you. What it helps you to become a good driver. Once you know that okay, in this month I have spent 5,000 rupees because I was braking too much on this thing, you'll be more cautious next time. It is good for the pollution, the mitigating pollution. It is good for the multiple things. So they started, if you are I mean, not driving properly and zigzag and this thing, they'll give you a very low rating on this thing, and they'll tell you that what are the possibility of you meeting the accidents and so on and so forth. So a lot of, I mean, this kind of thing they'll give you to straighten your behavior pattern, which one hand, when you go to the insurance agency and probably some car company or some taking the driving license, you will get some credit point out of it. And on other hand, you actually save some money. save the city pollution and so on and so forth. So these are the new things which are already there, especially in developed places like New York and all. You'll find I have put in, for example, I2D telematics have this kind of system of onboard unit. These are some of the things where like Dash actually has this mobile app by which they do it through these programs. And this putting these onboard unit are not very costly. I mean, they put off their cost, and this cost is recovered based on the benefits you get by the insurance and other things through that. So these are the emerging kind of technologies which provides you personalized information within your car. Make your journey safer. There's nobody else is involved between you and the car you are speaking, you and your driving habits you are speaking, you and your friends are speaking that you are a good driver, you're saving the pollution, you're saving the fuel, and so on and so forth. So these are a very emerging thing. In India they have not yet started too much. Little bit they may be here and there, but then they are going to come very fast with this. Summarizing the entire conversation, so it's a very very important aspect of our highway traffic management system. It decreases the accidents, it improves the emergency services, decreases the congestion, delays, infrastructure wear and tear, tax revenue it can increase, it can increase the satisfaction of the users. There are different types of few items I put in, and wherever I'm ticking it means that intervention if you provide within the traveler information system, then these benefits can be realized, and these are actually experienced uh, uh, by the various cities and the various things. So it's a very very important thing, and we should consider whenever we plan our highways or upgrade our highways to put this kind of information system. So this is all from my side. I'll be happy to take any questions you may have on this.
सर काफी इंफॉर्मेटिव सेशन रहा सर आपका। सर एक क्वेरी थी सर मेरी।
जी
सर
बताएं।
जैसे जितना भी आपने बताया सर, तो इसके रिगार्डिंग सर कोई भी मतलब या सेंट्रल गवर्नमेंट या कोई स्टेट गवर्नमेंट इसको एक सब कोलैबोरेट करके एक जगह कोई ऐप या कोई ऐसी वेबसाइट बना रही है जिससे जो यूजर इन्फॉर्मेशन जो आप बोल रहे हैं ट्रैवलर इन्फॉर्मेशन सिस्टम जनरेट हो सके और वो इजीली एक्सेसिबल हो सके?
या तो इसमें ऐसा था कि देखिए इसमें काम तो कुछ हुआ है। तो एक स्टडी की गई सेंट्रल गवर्नमेंट की तरफ से, स्पेशली कंट्रोल सेंटर्स बनाने के लिए वर्ल्ड बैंक की तरफ से फंडिंग उसकी आई थी 2016-17 में, जिसमें कि 2-3 उसके ऑब्जेक्टिव थे। एक तो उसमें था कि नेशनल हेल्पलाइन हम बनाएं, और उस नेशनल ट्रांसपोर्ट हेल्पलाइन एक बनाई जाए जिसमें एक नंबर हो और वो नंबर सारे मोड्स से कनेक्टेड हो। तो उसके क्या स्पेसिफिकेशन होंगे, उसके क्या डॉक्यूमेंटेशन होंगे, एक तो ये उसमें काम हुआ। और उसकी आप वेबसाइट पे अगर जाएंगे, महुआ की वेबसाइट, मिनिस्ट्री ऑफ हाउसिंग एंड अर्बन अफेयर्स के थ्रू हुआ था वो, तो उसमें ऑपरेशनल उसकी डॉक्यूमेंटेशन हुआ था, जिसपे कि डिलिब्रेशन हुआ, इम्प्लीमेंटेशन कुछ ज़्यादा हुआ नहीं। एक वो था। दूसरा ये उसी स्टडी के तहत ये भी किया गया कि ऑपरेशंस कंट्रोल सेंटर, बिकॉज कंट्रोल सेंटर इसका मेन नर्व है, एक्चुअली मेन सेंटर इसका है जहाँ डेटा आता है और जहाँ से डेटा जाता है। तो उसको कंट्रोल सेंटर्स को कैसे सेटअप किया जाए, तो ये इस पे भी फिर ऑपरेटिंग डॉक्यूमेंट बने स्टेट्स को असिस्ट करने के लिए। लेकिन जो आपका मेन सवाल है कि क्या किसी सेंट्रल एजेंसी ने ऐसा कोई प्लेटफॉर्म या वो बनाया, वो मुझे नहीं लगता। लेकिन अभी मेरे को ऐसा लगता है कि अभी हमारे ऑनरेबल प्राइम मिनिस्टर साहब ने जो पीएम गति शक्ति का एक पोर्टल बनाया है, उसमें ये सारा का सारा इंटीग्रेशन कुछ लेवल तक हो सकता है। तो पीएम गति शक्ति के बारे में अगर आप जानते हैं तो उसमें एनएचएआई और बाकी जितनी भी गवर्नमेंट एजेंसीज हैं उन सबको लॉगिन आईडी दिया हुआ है, और उनको अपने सारे प्रोजेक्ट्स को उसमें मैप करना है। हर स्टेट को उसमें लॉगिन क्रेडेंशियल्स दिए गए हैं, हमें भी दिए गए हैं। तो हम अपना प्रोजेक्ट मैप कर रहे हैं, आप अपना प्रोजेक्ट मैप कर रहे हैं। ये एक कंबाइंड डेटाबेस सबसे पहले बन जाएगा। एक बार आपके पास कंबाइंड डेटाबेस आ जाएगा तो उसकी बहुत सारी फिर लेयर्स को आप करते हुए इस तरह के सिस्टम्स को डेवलप कर सकते हैं। ये एक मुझे ऐसा लगता है फ्यूचर में कि एक बहुत बड़ा चीज़ बन सकता है। एक तो ये हुआ। एनएचएआई की तरफ से अगर हम बात करें तो 2004 में, और आप बाद में भी इस पे फिर काम हुआ था, रोड इंफॉर्मेशन सिस्टम करके एक प्रोजेक्ट किया गया था जिसमें मैं पर्सनली भी इन्वॉल्व था। और वो उसमें एक पोर्टल बनाया गया था जिसमें कि अलग अलग मॉड्यूल्स बनाए गए थे रोड इंफॉर्मेशन सिस्टम के, जिसमें ट्रैफिक इंफॉर्मेशन मॉड्यूल था, हाईवे में मेंटेनेंस रिलेटेड मॉड्यूल था, टोल मैनेजमेंट एक मॉड्यूल था। और इस सबको जीआईएस प्लेटफॉर्म पे लेके जितने भी नेशनल हाईवे थे उसकी इंफॉर्मेशन को उसमें इंटीग्रेट किया गया था। और फिर उसको एजेंसी के पर्सपेक्टिव से, यूजर के पर्सपेक्टिव से कुछ इंफॉर्मेशन, लेकिन एजेंसी के पर्सपेक्टिव से उसको HDM4 एक सॉफ्टवेयर होता है जो आपका मेंटेनेंस और इसकी स्ट्रेटेजीज और प्रोग्राम एनालिसिस करता है, उससे इंटीग्रेट करके मेंटेनेंस स्ट्रेटेजीज क्या हो सकती हैं और वो करके किया था। वो एक इनिशिएटिव था जिसमें 2010-11 में फिर कुछ थोड़ा काम हुआ, लेकिन शायद उसके बाद वो उतना आगे नहीं बढ़ा। ये छोटे छोटे बेबी स्टेप्स मैं कहता हूँ कि डेटा कंपाइलेशन, डेटा डेवलपमेंट के ये हुए। फिर हाईवे ट्रैफिक मैनेजमेंट सिस्टम करके एक वो किया गया। HTMS में क्या था कि आप अलग अलग तरह का डेटा, कंट्रोल सेंटर का डेटा और वो सब जो कलेक्ट कर रहे हैं, वो डेटा बेसिकली BMS के थ्रू और कहीं कहीं पे मतलब डिसमिनेट करने का कोशिश किया गया। लेकिन HTMS का मेन एक पर्पस ट्रेवलर इंफॉर्मेशन सिस्टम भी था। तो इक्विपमेंट तो लगे, लेकिन उसका जो रियल सोल था कि इंफॉर्मेशन प्रोवाइड कर दी जाए, सीसीटीवी को कर दी जाए, वो बैक एंड पे थोड़ा कम हुआ जितना मुझे आइडिया है। तो इन सबको मतलब ये थोड़े थोड़े स्टेप हुए, लेकिन मैंने कंबाइंड इंटीग्रेटेड सिस्टम अभी आई थिंक फ्यूचर में ही कभी देखने को मिलेगा, अभी तो नहीं है, ऐसा मेरा मानना है।
राइट सर। थोड़ा सर इन्फॉर्मेटिव मैं भी देना चाहूंगा सर।
जी बताइए।
बेसिकली आई एम फ्रॉम एनएचआई।
जी
तो जो आपने बताया कि जो वर्कआउट किया गया था, तो एक एनएचआई ने एक ऐप भी बनाया है जो सुखद यात्रा करके एक ऐप है।
जी
वो इजीली अवेलेबल है प्ले स्टोर पे, iOS ऐप पे। उसमें भी जाके कुछ इंफॉर्मेशन ट्रेवलर को मिल सकती है, लेकिन नॉट फुली। तो वो बेसिकली सभी इनिशियली तो देखिए सभी यूजर फ्रेंडली हैं गूगल मैप से, तो सब लोग इन्फॉर्मेशन उसी से ही कलेक्ट करते हैं कि एटलीस्ट ओरिजिन टू डेस्टिनेशन के बीच में मुझे कहाँ जाना है, मेरे अगर कहीं पहुंच गए डेस्टिनेशन पे तो क्या होटल लोकेशंस क्या है, एटीएम की लोकेशन क्या है, कैफेटेरिया क्या है। अभी तो सोलली रिलायबल उस पे ही है सर।
बिल्कुल।
सेकेंडली सर, जो आपने पीएम गति शक्ति वाला बताया, अभी पीएम गति शक्ति तो सर इनिशियल फेज में है बहुत। और पीएम गति शक्ति में तो अभी सारे डिपार्टमेंट्स को कोलैबोरेट करके एक प्लेटफॉर्म पे लाया जा रहा है, ताकि जो प्रोजेक्ट कहाँ डिले हो रहा है, किसकी वजह से डिले हो रहा है, उस पे अभी वर्कआउट हो रहा है सर। अभी तो इनिशियल फेज में। तो जो आपने बताया सर, ये तो मतलब मुझे लगता है आज से 10 साल के बाद का प्लेटफॉर्म हो पाएगा कि हम लोग कहीं एक फिर इंफॉर्मेशन शेयर
डेटा
करेंगे
आ
कि ये
जाएगा तो
हमारा
शायद जल्दी
इंफ्रास्ट्रक्चर
हो
डेवलप।
जाए। देखिए उसका पर्पस तो मल्टी इंटीग्रेशन है ही।
बिल्कुल
तो
सर।
10 साल तो नहीं लगने चाहिए, बट डेटा आ गया तो देखिए ये तो सिस्टम बनाना आसान है।
सर राइट सर।
बिल्कुल।
थैंक यू सर।
थैंक यू। So anybody else, if it is having any question, please.
Thank you, sir. Good information from your side.
Thank you. So Neeraj ji, in case there is no other question, then we can close the session.
Yes, sir.
Okay, so thank you everyone.
Thank you so much, sir.
And yeah, I'll share the presentation to you, Neeraj ji, on this thing, and then you can share with the participants.
Okay, sir. Thank you, sir.
Okay, sir. Thank you everyone.
थैंक यू सर।